Hello everyone, welcome to the session on digital electronics. In this session, we'll be discussing about encoders. In this session, we will see what we mean by encoders. We will see the design of decimal to BCD encoder, and also we will see what we mean by the priority encoder. Friends, as you know that you are viewing this session on my YouTube channel Learn with Prakash Khanade, and do subscribe to the channel to see many videos on the subjects of electronics and computer science. So let us start the session with the question what we mean by encoders. Encoder, you can say that it is a digital combinational circuit that will convert the input information into coded form. So the input information that is available at the encoder is in understandable form. So it is normally a human understandable information, and the output of the encoder is some code of the input information. So you can say that encoder is a combinational circuit that will perform the reverse operation to that of decoder, because decoder will convert the input code into understandable information, while the encoder will convert the input information into coded form. You can say that encoder is a block where it will have 2 raised to n input lines and it will have n output lines. So you can say that the input that is being available at 2 raised to n inputs is being coded into the n bit code. So actually encoder is providing at the output a kind of binary code which is equivalent to the input information. And therefore we can say that encoder encodes 2 raised to n input lines with n bits. There are different types of encoders. Say for example, we can have a decimal to BCD encoder where the input decimal information is being coded into BCD form or binary coded decimal form. There is another type of encoder, and this encoder is being called as a binary to octal encoder. So the input binary information can be converted into octal form. So it is possible that we can build a large variety of encoders. Encoders are very useful combinational circuits because they can be used in many devices such as calculators, ATM machines, computers, mobile phone, and even in our televisions. So let us go for the discussion of decimal to BCD encoder. So as shown in this block diagram, a decimal to BCD encoder will accept at the input a decimal information which is from 0 to 9. So it will have 10 input lines and it will convert this information into BCD output. That is, there will be 4 output lines. So as we know that encoder is a digital circuit that will convert the input understandable information into the coded form. Decimal to BCD encoder will convert the input decimal information into BCD output. Now we know that the input is the decimal information, and decimal information is human understandable information. So such information is being coded into a BCD output, which is a coded form of the input information. Now we can easily understand that this encoder will have the 10 input lines from 0 to 9, and it will have only 4 output lines. IC 74147 is a very popular decimal to BCD encoder. So whenever in certain application you need to make use of this decimal to BCD encoder, then you can make the use of this IC 74147. Now let us go for the design of decimal to BCD encoder. Now we know that this encoder will have the 10 inputs and there will be 4 outputs. Many ICs will have the strobe input or enable input, and we know that for the proper working of this IC, it is necessary that the strobe input should be equal to 0 when it is active low. Now this can be the truth table of this encoder. The input information can be anything from 0 to 9. So if the input information is 0, then the output of the encoder will be 0000. So whenever this input line 0 is being activated, then you will get the output 0000. When the input line 1 is being activated, then the output of the encoder will be 0001. For 2, the output will be 0010. For 3, the output will be 0011. So when the input line 4 is activated, then the output will be 0100. For 5, the output will be 0101. For 6, the output will be 0110. For 7, the output will be 0111. For 8, the output will be 1000. And for 9, the output will be 1001. So for encoder, out of the 10 inputs, it is necessary that some of the input must be activated, and then the corresponding code will be generated at the output. So from this truth table, we can easily write the equations for the outputs. So when you look into this column of D, you will find that for the decimal 8 and 9, the output D is 1, and therefore I can write the code D is equal to 8 plus 9. Similarly, when you check the columns for output C, then you can note that for the decimal inputs 4, 5, 6, and 7, the output is 1, and therefore you can write the code C is equal to 4 plus 5 plus 6 plus 7. Similarly, when you check the column for output B, then it is 1 for 2, 3, and 6 and 7 decimal inputs, and therefore we can write the code B is equal to 2 plus 3 plus 6 plus 7. And when you check for the output A, then you can easily find from this truth table that for the decimal inputs 1, 3, 5, 7, and 9, the output A is 1, and therefore you can write the equation A is equal to 1 plus 3 plus 5 plus 7 plus 9. So if you want to construct the logic circuit for the encoder, then by using the OR gate, we can easily construct the logic circuit for decimal to BCD encoder. So here it is a logic circuit for decimal to BCD encoder, where you will find that the first output A is the output of the first OR gate, and its inputs are 1, 3, 5, 7, and 9 as per the equation. Similarly, the second OR gate will have the inputs 2, 3, 6, and 7, and its output will be equal to B. The third OR gate will have the inputs 4, 5, 6, and 7, and its output will be C. And the fourth OR gate will have the inputs 8 and 9, and its output will be D, where D is the most significant bit of the BCD code, and A is the least significant bit of the BCD code. So by using 4 such OR gates, we can easily construct a decimal to BCD encoder. As I told you, IC 74147 is a very popular IC that can be used as a decimal to BCD encoder. Now we will go for the discussion of priority encoder. Now, when we consider any encoder, then one can easily find that there are certain drawbacks that are associated with the encoder circuit. So basically, there are two drawbacks that are associated with the encoder circuit. So the first drawback is that when all the outputs of the encoder are equal to 0, then there will be an ambiguity for the encoder circuit. And similarly, when more than one input of the encoder is active or it is high, then the encoder will produce an output which may not be a very correct code. So it is necessary to overcome these difficulties which normally arises with a normal encoder. And therefore, to overcome these difficulties, what we need to do is that we need to assign a priority to each input of the encoder. And such encoder is being called as a priority encoder. Now, whenever we have some priorities assigned to the inputs, then the output of the encoder will be the code corresponding to the active high inputs, which has the higher priority. So the input that has the higher priority will be given the preference, and accordingly, the output will be generated by the encoder circuit. So for example, we will consider a 4 to 2 priority encoder. As shown in this block diagram, this encoder will have 4 inputs D0, D1, D2 and D3, out of which D0 will have the least priority or lowest priority and D3 will have the highest priority. And suppose this encoder circuit has two outputs Y0 and Y1. So this encoder, priority encoder, will have the 4 inputs D0 to D3 and it will have only two outputs Y0 and Y1. So as I told you, D3 is supposed to be the highest priority input and D0 is supposed to be the lowest priority input. Now we can easily consider or construct the truth table for this priority encoder. So the inputs are D3, D2, D1 and D0. When all of them are 0, then we do not expect any output. So Y1 and Y0 can be indicated by the X symbol. When D0 is 1 and D3, D2, D1 are 0, then you can expect the output equal to 0, 0. When D1 is 1 and whatever may be the value of D0, then the output should be 0, 1. When D2 is 1 and whatever may be the value of D1 and D0, then the output should be 1, 0. And when D3 is 1 and whatever may be the values of D2, D1 and D0, the output of the encoder should be equal to 1, 1. So one can easily understand from this truth table that the input which has the higher priority output will be in accordance with the highest priority input. Now we can construct the truth table. We can construct the equations. For constructing of the equations, we can construct the Karnaugh map, isn't it, for both the outputs Y0 and Y1. So when we plot the Karnaugh map for Y1, then we can plot it as shown in the figure. And similarly, we can plot the Karnaugh map for the output Y0. Now from this Karnaugh map, once we solve them, then we can easily construct the equations for the outputs Y0 and Y1. So this block will correspond to the D2 and this block will correspond to the D3, and therefore we can write the equation for Y1 is equal to D2 plus D3. And similarly, we can write the equation for Y0 is equal to D2 bar or D2 dash D1 plus D3. Now, once we got the logic equations, then we can construct the logic circuit for the priority encoder. So as shown in this diagram, there are 4 inputs D0, D1, D2 and D3. The output Y1 you will get according to the equation D2 plus D3. So D2 and D3 are coupled to this OR gate and the output of the OR gate will be equal to Y1. Similarly, we will get the output Y0 according to the equation D2 bar D1 plus D3. So D2 is complemented by using an OR gate and it is connected to the AND gate. The output of the AND gate will be D2 bar into D1 and it is ORed with D3 to get the output YO. Now observe that this circuit priority encoder will have one more output and that is being called as output V, and the output V is 0 only when all the inputs are 0. Otherwise, the output is equal to 1. So actually, this output will indicate whether the input is valid or not. So if all the inputs are equal to 0, that is none of the input is active, then in such a case, the V will indicate that the input is invalid. So input is valid or not, that is being decided as per the output V. So one can easily observe that the output V is obtained from an OR gate where the inputs are D0, D1, D2, and D3 are the inputs to the OR gate, and its output is being called as a valid check for the input. So thank you friends for viewing the session. Hopefully you have understood what we mean by the encoders and how it is possible to design the decimal to BCD encoder and the priority encoder. Thank you all for viewing the session.